I'm Linda Rosen, the CEO of Change the Equation, and I will, before my remarks over, introduce this illustrious panel who have very graciously given their time this morning. They may have to scoot a little bit, and we'll be very respectful of that as well in getting started, but we'll get your questions answered. How well we educate our urban students is an important measure of how well we educate all our students. The 100 largest districts in the United States, many of them urban, educate approximately a quarter of our nation's students. And they also serve an enormous share of students who are poor and students of color. In this nation, which is undergoing dramatic demographic shifts, our success in improving urban schools is critical to our success in preparing a workforce that can adapt to a fast and changing global society. The Trial Urban District Assessment is a critical tool for charting progress as a nation, and all of us, whether we're here with our educator hat, our parent hat, our policymaker hat, and certainly the more than 100 CEOs in the Change the Equation Coalition have a profound stake in the results. And I've certainly been working in this arena long enough to know that there was a time where we didn't have results from urban districts, and that the very fact of their existence is a profound step forward in knowing the data and being able to make decisions. So let me just say a word or two about Change the Equation. It's a nonpartisan, nonprofit coalition of CEOs dedicated to improving the quality of learning in science, technology, engineering, and mathematics in the United States. We were formally launched in September 2010, and our focus is on groups not well represented in STEM mastery, which makes our interest in the urban districts all the more important and all the more timely. Our game and our aim is to improve our members' philanthropy and their advocacy, and to ensure that we do our part to inspire students about the importance of STEM learning. On the philanthropy side, we've worked with our member companies to scale up excellent programs to new sites across the country with a special eye on our traditionally underserved student population. We call this initiative Igniting Learning. On the advocacy front, we released just last week a new report called All Over the Map, and I hope you picked up copies in the back, which find that there are huge disparities in where states set the bar for student achievement in 8th grade science. So when I mentioned that we were launched in September of 2010, you realize we're just a little over a year old, and I would like to show you a very brief video clip that shows what a busy, productive year we've had.
On September 16, 2010, a group of visionaries joined forces with more than 100 of America's leading CEOs, making a shared commitment to answer President Obama's clarion call that we must educate to innovate and strengthen America. The result? Change the Equation, a nonpartisan, nonprofit coalition committed to improving the teaching and learning of science, technology, engineering, and mathematics, collectively known as STEM, across America, both in and out of school. Change the Equation's quest to create widespread literacy focuses on 3 goals: great teaching, inspired learning, and a sustained commitment to widespread STEM mastery. It focuses on girls and students of color who are underrepresented in STEM achievement. In its inaugural year, Change the Equation harnessed the best thinking and resources of the coalition to guide its work, developing design principles and tools to foster effective philanthropy in STEM learning. Vital Signs, the first in a series of influential reports on the condition of STEM learning in every state in the nation, was released. STEMtistics spotlighted important data that told a compelling story and guided the STEM conversation from ho-hum to aha. The STEM is Cool campaign challenged the coalition to showcase the innovative, exciting, and often unexpected STEM-related work that their employees do every day. And they adopted the mantra of igniting learning by expanding a select number of high-quality STEM opportunities to nearly 140 sites, reaching tens of thousands of students nationwide. And that's just year one as we move to change the equation. Because a literate nation not only reads, it computes, investigates, and innovates. Be part of the network. Learn how at changetheequation.org.
So let's jump into the Trial Urban District Assessment. The National Center for Education Statistics of the U.S. Department of Education released TUDA, as it's familiarly called, just last week. And here's some background that might be helpful as a context. TUDA began in 2002 with 6 urban districts participating in the National Assessment of Educational Progress, what we love to call NAEP, reading and writing tests. In 2011, 21 districts participated in reading and mathematics. TUDA allows districts to track their progress and compare their results in ways they could not do previously, that is, against a common yardstick. We are delighted today to host 3 esteemed guests who can share insights into the TUDA results and their implication for the nation. So let me introduce our panelists in the order in which they will speak. First, we have Jack Buckley, the Commissioner of the National Center for Education Statistics. Prior to leading NCES, Jack was an associate professor of applied statistics at the New York University and deputy commissioner of NCES from 2006 to 2008 under former NCES Commissioner Mark Snyder. Jack has also been with Teachers College, Columbia University, Georgetown University, Boston College, and SUNY Stony Brook. Jack spent 5 years in the U.S. Navy as a surface warfare officer and nuclear reactor engineer, and I suspect he was happy with the results of the game this past weekend. In contrast to that, that's right, that's where I'm going to get. Mike Casserly has served as the executive director of the Council of Great City Schools since January 1992. As head of an urban school group, Mike has unified the big city schools nationwide around a vision of reform and improvement, and really made significant strides in bringing this group of sometimes disparate characters together. Herding cats, I think, is a phrase that might be used. He has led the nation's largest urban school districts to volunteer for NAEP, which is the topic of today's discussion. And as I forecast before, Mike is a U.S. Army veteran who's not so happy about the results this past weekend. Seated next to me is Carlos Contreras. He is the U.S. Education Director for Intel Corporation, a wonderful friend to Change the Equation. And I'm not so happy that he's moving back to Arizona, and I just have to turn the knife a little more publicly, but he is. He has been at Intel for 14 years, but I've got him on speed dial. Before joining Intel, he was a process engineer with Procter & Gamble in California. Carlos oversees Intel's education programs, many of which focus on science, technology, engineering, and math. And let me turn it over to Jack with that.
Thanks very much. So, as mentioned, we released the National Center for Education Statistics, released the TUDA Trial Urban District results for reading and mathematics last week. But about a month before that, we also released the national and state results. And it's been a very busy year for NAEP, and so I'll actually draw today, with the time permitting, I'll draw on some of our earlier results, in particular the high school transcript study, which uses data from 2009 and looks at a wide range, particularly in mathematics and science course taking. And so I know it's of interest, and so hopefully we can set some of these results in broader context. So TUDA is a collaboration among us, NCES, the National Assessment Governing Board, who sets policy for NAEP, and the Council of the Great City Schools, represented by Dr. Casserly, without whose help it would be impossible. And so it's a very interesting, sort of complex endeavor in terms of getting large urban districts to voluntarily allow us to measure them in a way that is comparable across districts and comparable to states in the nation, and really shines a bright light on achievement over time and for different subgroups of students. And you know, without that willingness to participate, this is just sort of information we simply wouldn't have. In general, of course, the purpose of NAEP, as you know, and as your own, as Change the Equation's own report shows for science, the recent report, there's, you know, within our own states, there's no common yardstick or ability to compare across states. States set their own curricula, they set their own assessments, performance metrics, and it's very difficult to compare among them, which is why we need something like NAEP, which is a common national assessment in many subjects. So I'll talk today primarily about mathematics, but we do assess students in reading, we assess students in writing, in history, civics, geography, the arts, you know, a broad range of topics, and it's the only single, you know, common yardstick across the entire country in any of those subjects. So we have 21 districts participating in the most recent assessment. This shows, I think we're animated here, yeah. In 2009, between 2009 and 11, we added 3, Albuquerque, Dallas, and Hillsborough County, Florida, but you can see the rest of them sort of spread all across the country. And they're not just spread out geographically, right? I mean, if you know anything about a lot of these cities, they're very different in terms of the urban districts. And actually, I think I've got a slide about that in a moment. So I'll get back to just sort of how different they are. It's very important to realize that we're talking about a very disparate group. So in general, what we're reporting in TUDA is based on a representative sample of public school-only students in these districts. And the sample size ranges depending on sort of the heterogeneity of the district and the size. The national results that we also report include private school students, but there aren't enough of them sort of sample-wise at the state or district level to break them out. And they're not mandatory in the states the way public schools are. And so we only report data that include private school students only at the national level. In general, all of our reporting, as I'm sure you've seen before, uses a couple different outcome metrics. We put our assessments on a scale score, and so for mathematics, these scores range between 0 and 500 points. But we also report out the percentage of students at or above various achievement levels, right? So the achievement levels are set by the National Assessment Governing Board, and they are designed to tell us not just sort of what kids know, but how they compare to what the governing board thinks kids should know and be able to do. Their policy target is proficient, but their idea, you know, the governing board's idea of proficient, as we measure it, is definitely more rigorous than almost any state who using the same word as part of No Child Left Behind. So you know, I think the formal definition of proficient for NAGB is competency over challenging subject matter, right, which is a higher bar in general than sort of grade level, right, or some other notion. So it's important to realize even if the word proficient, you hear various, you know, contexts or usages, that, you know, NAEP's idea of proficient is generally more rigorous than a typical state assessment program. Today I'll compare district results to 2 sort of reference groups. First of all, the nation, so national averages, but also we can compute a separate comparison score for averages of large cities, what we call large cities. So in this case, we're talking about any area in the United States with a population of 250,000 or more, any sort of urban area. This is obviously because our TUDAs, you know, maybe the nation isn't always the best thing to compare individual districts to, and so we compute these large city statistics as well. And where possible, I'll show you trend. Of course, we don't have any trends for those 3 new districts who just joined us. So I mentioned just a second ago that our districts are very heterogeneous, right? There's an amazingly broad range of characteristics. And so just to show you here's an example, just a few characteristics you know, of the many we measure, and just plotting here the range that we observe in the 21 TUDAs. And so, for example, you know, looking at the percentage of students who are black, while the national average is 16% and our large city average is 27%, we have TUDAs ranging from 2% to 87. 87% is Baltimore City Public Schools, actually where we released the TUDA results last week. And if you look at the next line, the 3% left end of the range for Hispanic students is actually also Baltimore City Public Schools. And so we have a wide range of very different districts. Down at the bottom, in particular, students from lower income families. So the national average is 52%, which is quite high actually, and has gone up every 2 years for the last 4 or 6 years. What we see is one of our TUDAs, Charlotte Mecklenburg, actually is right at the national average. And then we've got some TUDAs that are at the very high extreme range. For example, 100% of our sample in Cleveland are students who are eligible come from families who are eligible for free or reduced price lunch. So there are some cities out there with extremely poor student demographics. All right, so looking at the math results. First, here I just try and show quickly, sort of qualitatively, how do the average scores in the TUDAs compare to the large city average. And so the column on the left shows the districts where their average in 4th grade, this is 4th grade math, is higher than the large city average. And the 3 districts in blue are actually higher than the national average as well, right? So those are the highest performing grade 4 districts among the 21. So you can see there are some districts who are outperforming in grade 4 the large cities. There are 3 in the middle who are statistically tied, right? So these are indistinguishable statistically from the large city average. And there are quite a few districts whose grade 4 math average was lower than our large city average on the right. We can look at the trends over time. The numbers in the triangles are probably a little bit small for you. But what we're trying to show, if a green triangle is present, this denotes that there was actually an increase. And so the column on the left of triangles is looking back over the longer trend in grade 4 to 2003. So what you can see there's generally a lot of triangles where data are available, so where we actually observed that city in our sample back to 2003, there's been an increase, right? In general, there are increases, in fact, for every TUDA for which we have data except for Cleveland in grade 4 mathematics, looking back over the longer trend. When we look just over the most recent trend, so this is from 2009 to 2011, the right column, what you can see, again, where there has been change that we're able to detect, it was an increase, so it's good news, but there's sort of far fewer increases over the last 2 years, just looking at the shorter time trend. So actually only Atlanta, Austin, Baltimore, and Philadelphia had an increase in average scale scores between 2009 and 2011. And all those gray diamonds are just showing that something was statistically identical to 0, right? They're not significant in a statistical sense. We also look here at the percentages for each district of grade 4 students who are at or above the basic level. And what you can see, again, as you'd expect, given the very different districts we have, is a broad range of sort of performance. So the first sort of cluster are students, or districts rather, where the percentage of students at or above NAEP's basic level is larger than the large city percentage. And the ones in the middle are not significantly different statistically, and then the group at the bottom are lower. So you can see the percentage, if you look at the darker green bar on the left, that's the percentage below basic, so not attaining NAEP's basic level. So only 12% of students in Charlotte there at the top were below NAEP's basic, but 66% of 4th graders in Detroit at the bottom were below NAEP's basic level. So again, there's a wide variation among the cities. And the very top 2 bars show the national and the large city averages for comparison. So turning to 8th grade, again, we can look at how the cities compare to the large city average. And again, the 2 here, in this case, the 2 in blue, Austin and Charlotte, are also higher than the national average. So the column on the left are the highest performing districts. And there are still a significant number in the right column which had a lower average than the large city average. Looking at the trends, the story is pretty much the same. Where we have data going back to 2003, in general, there's been positive growth for just about every district except for Cleveland. And then comparing to 2009, again, where there was some statistically detectable change, it was an increase, but there are more districts where we weren't able to detect a change. And so Jefferson County, Kentucky, DCPS here, Detroit, Chicago, Charlotte, and Atlanta, we all see statistical improvement over the last 2 years. And so, again, I would say, while not it's not improvement across the board. It's generally a positive story, right? There's not evidence of decline, and when you look back over the long period, some of the growth for these cities has been really significant, right? You've got some back to, comparing to from 2003 to 2011, we've seen really some meaningful growth. Again, a lot of variation in the percentage of students at or above basic, ranging from 29% at or above basic, which is down in Detroit, to 74% in Austin at the top in the 8th grade. All right, so another thing that and Mike, these are new, so Mike's been, I think you've seen me give this presentation maybe 4, 5, 6 times in the last month, so just for you, I put some new slides in. So we wanted to, so one thing we have in NAEP are a lot of, we call background questions, right? There's a lot of other data that we collect besides just the assessments. And what I tried to do is for both 2011, but also for the most recent science results for Science TUDA in 2009, which we released in February of this year, we also wanted to show sort of some range on these background characteristics. And so in this case, again, what we're looking at are one of the questions we ask kids at various grade levels, sort of simple attitudinal items about how much they like math and what their efficacy is, right? How good they think they are at it. Now we know that, this is not causal, right? I'm not saying, if we can just force a kid to like math, then they're going to perform better. On the other hand, depending on who you talk to, if they don't even like math, you're going to have difficulty getting them in the door for more advanced courses down the road. And so, I thought it would be interesting to look at the variation. So in math, we see the national average is about 42% of 4th graders who report that they always or almost always like math, enjoy math. 40% there is the anchor point for among the TUDAs is Albuquerque, and 59% is actually Dallas. And then the TUDAs all sort of fall in the middle there. Science, we also see some variation. About a third of our students in the 4th grade report that they almost always or always enjoy science. And that ranges from a low of 27 in Milwaukee to 47 in Los Angeles. Looking at 8th graders, in general, the numbers are higher. So you see in the nation, it's about 2/3 of 8th graders are going to tell you that they like math or science almost all the time. They strongly agree. We do see some variation among the TUDAs. So there's a low there of 60% in Miami-Dade to a high of about 78% in Chicago. And a low of about 59% in science for Miami-Dade and a high in Atlanta. Now, one of the things, if you follow this, NCS is also responsible. We collect all the data for international comparison. So we are the U.S. Administrator of Pisa and the TIM study, which I'll talk about a little bit later, and PEARLS. And one of the findings that always gets attention from those studies is the general sort of unexpected correlation among variables like this and outcomes, right? So you look at countries where the kids report that they're more engaged in math or science, or countries where the kids that will tell you that they like math or science more, and generally those countries score lower, right? So you see sort of for you, the downward sloping line, where the countries where the average kid attitude is more positive generally has a lower average score. We actually see this pretty much here as well. The thing is, if you look within any of those jurisdictions, the relationship is almost always reversed, right? So among students in a given country, the more they like science, the higher their performance is on average. But when you aggregate and then compare across the countries, you see something different. So part of that, I think, is there's some issues within the international data, there's some issues in cross-cultural comparability and survey response. But there's also something interesting going on where you really need to know probably what's going on in terms of the variation within these districts, in our case districts, and also within these countries, because they're so different that when you make those higher level of aggregate comparisons, be careful what you're getting at. So this is another sort of similar question where we're asking whether or not math is your favorite subject. So about 40% of 4th graders tell us in the nation that math is their favorite subject, and only about 27% tell us that science is their favorite subject. And again, there's a lot of variation there. With the highs in this case are Dallas and Jefferson County, Kentucky for science. And in 8th grade, again, in this case, not overwhelmingly a big jump, but again, you see about half of the nation will tell you that, in 8th grade, will tell you that math is their favorite subject, and about 45% science. I'm always surprised by that. I'm surprised that about half of 8th graders will tell you that math is their favorite subject. I don't know if I believe them, but, but they're happy to tell us that. No, it can't be a bad thing, but it is a little bit surprising to me. What you see there is the range in math is.
You're a bunch of math teachers.
No, I know. I'm a little. So these attitudes. Again, I gave you my caveats. I am a little bit more hard-nosed guy, and so I'm more interested in actual behaviors than I am in attitudes generally. And so one of the things that we measure in NAEP and in other surveys in NCS is course taking. And with our transcript studies in particular, we go in detail and analyze kids' transcripts in high school. In this case, we ask 8th graders which mathematics course they're currently enrolled in. And so if there's many math teachers here, then you all know about the discussions around the sequencing for Algebra 1 and its importance as a gateway for further STEM coursework. And so what we see, for example, is about a third of 8th graders are enrolled in Algebra 1 as a one-year course when we assess them. And our testing window is from about January to March. So it's in the spring. If you're taking Algebra 1, by the time you're taking it in 8th grade, we will have, when we're asking you, you will have taken it. So we see nationally about a third of the kids are in Algebra 1. There's a lot of variation in our TUDAs. Actually, the 11% is in Atlanta. Only 11% of 8th graders are in Algebra 1 in Atlanta, but about 77% in Hillsborough County, so Tampa area in Florida, are in Algebra 1. If you're not in Algebra 1, you're probably taking something else. We look at sort of a pre-algebra in 8th grade, where across the nation it's about 22%, ranging from a low of 4% in Hillsborough to a high of 29% in Miami. And then if you're not in pre-algebra or Algebra 1, you're taking some kind of general or basic 8th grade math. And in that case, again, you've got about a quarter of the nation of 8th graders are enrolled in that sort of course, ranging from, in our TUDAs, from a low, again, in Hillsborough of 3% to about half in Austin. 54% in Austin Independent School District are in basic or general math. We also can look at who took what in science. Again, these are 2009 data from our TUDAs. So we're asking, in this case, again, because they may not be enrolled in a science course with a particular name, we actually ask them more about topic coverage. So what were you studying these things with examples in the questions? And so, again, about 42% of 8th graders reported that they were taking math, life sciences. About 81% identified some of their course was covering physical sciences, and about 56% in the nation were covering earth and space sciences. You can see, again, a lot of variation. So just looking at life sciences, the low there is San Diego, about 31%, and the high was Detroit, 92%. So 92% of the students in Detroit reported that they had covered some sort of life science in their 8th grade science curriculum. So one of the reasons why you may or may not be covering something in a particular grade is whether or not you actually have access to the coursework, right? So there's a lot of sort of hurdles that have to get over, students have to get over before they can even take some of these courses. This is data from the high school transcript study in 2009. And we were interested, in this case, and now we're moving beyond 8th graders. So I'm looking at, these are graduates of high school. So in order to be in the population for the high school transcript study, you actually have to have successfully graduated high school, and we can go back and look at your transcript, so there's some selection there. And we were curious about where AP math and what we call advanced math, which is essentially math after Algebra 2, where these were being offered, just in terms of types of schools. And so you can see, for example, if you're in, here we break it down by sort of two variables, right? So we're looking at whether or not you're in a city, a suburb, a town, or a rural area, and those are technical definitions, but they sound about like what they sound like. And then within those, we stratify on the percentage Black or Hispanic, so disadvantaged minority status in the school. And so looking at the city column, for example, if you are in a low minority urban area, about 95% of you students had access to AP Math, right? AP Math was offered. However, if you were in a higher, so greater than 50% minority urban school district, or school rather, 86%, only 86% of you as a 12th grader had the opportunity to even take AP Math that was offered in your school. When you look down at the rural areas, you can see it's sort of a lot more variation, right? So the top of the 3 bars within the rural bottom bar shows for low minority rural areas. So we're talking about primarily our sort of, Appalachia, sort of low, very white, often very poor rural areas. Only about half of the students in those high schools have access to AP Math. If you're in a higher minority rural area, it's actually closer to what you see in the urban areas. So more like 89, 90%. Science is a similar pattern, although in some cases it's more stark. And our thinking on this, as you would probably guess, particularly with AP Science, is one thing, you can figure out a way to offer an AP Math curriculum. If you can, it's a human capital question. Can I get a math teacher? Can I find a distance education solution? If I need to offer AP Science, I probably need labs, right? And so now I have a bigger resource problem, and it's harder to get in there and actually offer the courses. And so again, you can see in high minority urban areas, only about 80% of students even have access to AP Science. And in low minority rural areas, again, only about half of students have access to any kind of AP Science curriculum. And you can see some other interesting variation there. You get down in the 70% in towns. So in our towns, you can still find a lot of schools where 30% of the schools or so will not have access to any sort of AP Science at all. All right, so there's, as always, there's a ton more information in all these different reports that we're drawing from here. A good place to start is at the nationsreportcard.gov, which will point you to all the various subjects. I always have to put in a plug for the fact we've got some great online tools as well. So you can look at our released items. There's a questions tool where you can actually build your own assessments and also look at all the questions that we've ever made public over the years, which are quite a few, hundreds and hundreds, if not thousands. There's also something called the NAEP Data Explorer, which actually lets you do your own analysis. So you can take an outcome measure like math achievement and build your own tables on the background variables that you might be interested in, and you can perform your own analysis with our data, because no matter how big our reports get, we never answer everybody's question. And so the tool will actually let you do that yourself. At that, turn it over.
First of all, I just want to thank you for the invitation to be here. I'm Mike Casserly. I'm the Executive Director of the Council of the Great City Schools. I assume everybody knows who we are, but for those of you who don't, we are a coalition of the nation's largest urban public school systems. It's been over 10 years now since I first went to the National Assessment Governing Board and proposed having cities oversampled on a volunteer basis to take NAEP in a way that would yield them district-specific information in reading, math, science, and writing. As you might guess, people really thought that I was crazy. People probably still think I'm crazy for having suggested that urban public schools volunteer to take the nation's toughest test, but we set up the project with NCES and the National Assessment Governing Board because of 3 underlying purposes. One, we wanted to make it crystal clear that urban public schools and our coalition was fully committed to the highest academic standards for our kids, and it's the same reason that led us to be such aggressive supporters of the Common Core standards. Second, we wanted to be able to compare ourselves individually and collectively with each other and with the nation. And finally, we wanted a common way to gauge our progress and evaluate our reforms in ways that the current 50-state assessment system simply did not allow. Now, since that time when we first proposed this project, it's at least clear to me that we made the right decision to launch this thing for the right reasons, and that a lot of the things that motivated us to set up this project in the first place are now starting to come to pass. I think the data are starting to bear fruit in ways that we had not even originally envisioned when we set this up. Now, with the results that came out just last week on 2011 in mathematics, I have to say that we were generally encouraged by the results. We weren't pleased, but the math TUDA results for 2011 were generally headed in the right direction, and we were encouraged by that. In general, the nation's large city schools saw significant gains in math at both the 4th and 8th grade level between 2009 and 2011, a period, by the way, that was, as you know, marked by substantial budget cuts and growing poverty rates and increases in, or decreases in the rates by which we excluded kids. So we actually had many more kids in the cities taking these math tests than we had had in the past. Maybe more encouraging, however, to us was the gains that we have seen since we first started to take the NAEP math tests in 2003. As you can see from this slide, between 2003 and 2011, the percentage point gain for large city students scoring at the proficient level or better in math has gone up 50% among 4th graders and 63% among 8th graders, gains that substantially outpace the nation, as you can see from this exhibit. Conversely, the percentage of 4th graders in the large cities scoring below basic levels of attainment has dropped by 30% between 2003 and 2011, and the percent of urban 8th graders scoring below basic levels has declined by 26%. All this means that some 60,000 more urban 4th graders are now doing math at proficient levels or above than they were in 2003, and some 66,400 fewer 8th graders are doing math at below basic levels than used to be the case, a net shift upwards across the performance levels of over 127,000 urban 4th graders. The shifts are even more substantial when it comes to the 8th grade. Second, the data suggests that we are starting to narrow the gap between us and the nation in math performance. Between 2003 and 2011, the difference between the large cities and the nation in 4th grade math has declined from 10 scale score points in 2003 to 7 scale score points in 2011. At the 8th grade level, as you can see from the graph on the right-hand side, the gap has shrunk from 14 scale score points to 9, all at a time when the national scores were going up at least some. In other words, the math gap between the large cities and the nation has shrunk between 33 and 36% over that 8-year period. Third, most of the individual cities have also seen gains in math that are at least nominally greater than those made by the nation. On this graph, you can see large cities in light green and the nation in, I think that's red, or a version of red. The difference between the gains in the large cities and the nation are statistically significant, and then you can see how the size of the gains in the individual cities. So in this case, you can see that not only the large cities in the aggregate have posted math gains that are statistically significant and statistically larger than the nation as a whole, but that most of the individual cities have seen significant gains since 2003 and gains that were at least nominally larger than the nation as a whole. 4th grade gains were particularly noticeable, as you can see, in Boston, D.C., San Diego, Atlanta, Chicago, and Houston. At the 8th grade level, you can see really noticeable math gains in Boston, Atlanta, Chicago, Los Angeles, Houston, San Diego, and D.C. We think of particularly noteworthy in terms of math gains has been in Boston, which ranked either first or second in the size of gains between 2003 and 2011 amongst all of the cities participating. I think the 8th grade math gains in Boston are also larger than any other jurisdiction, local or state, between that period. Now, our organization just finished a major study looking at Boston's math gains and contrasting it with Cleveland's nearly non-existent math gains over that period to see why the districts showed such significant difference in movement. We also looked at where the cities were in general in terms of their overall strengths and weaknesses in math as we went down to the subscale, strand, and item levels, and how these strengths and weaknesses were likely to affect our performance on the Common Core math standards. We also examined who seemed to be getting the best results after adjusting for various student background variables, how alignment or lack of alignment affected NAEP results, and what reforms appeared to produce NAEP gains. The contrast between Boston and Cleveland we thought was particularly interesting because the two cities had similar 4th and 8th grade math scores when we started this process in 2003. I think there was only a 5 scale score point difference between Boston and Cleveland in 2003. Both of them were substantially below the national average. But by 2011, Cleveland remained almost exactly where it was in 2003, but Boston, by 2011, in 8th grade, was not significantly different from the nation. Interestingly enough, both cities over that period of time used exactly the same math programs. How could this be? And how did it affect and inform our attempts to improve and implement the Common Core standards? Now, we probably don't have time for me to go into all of the specifics behind why these differences, but in general, what we found that largely that seemed really different in these two places had to do with their overall leadership, their staff stability, how it is they envisioned their reforms, how it is they held people responsible for the overall math results that they got, how the programs were rolled out and implemented, how they were supported, not the program themselves, but how the program was supported, the quality of the professional development, the retention of the teachers and how they were trained, and how it is the districts used the data to inform the math instruction that they were pursuing. The NAEP data in general is also telling us a lot, as I suggested, about what problems we are likely to run into as we implement the Common Core. For instance, our 4th graders often did poorly on such number sense problems as adding or subtracting fractions with like denominators or decimals through the hundreds place. Even Boston 4th graders, as a matter of fact, had trouble with that particular set of issues. Yet the Common Core standards in math, as you know, place early emphasis on fractions and decimals and understanding place value. In general, the Common Core places more emphasis on mathematical fluency, deep understanding, and application, all areas that NAEP data are telling us our kids are likely to have problems if we don't implement the Common Core adequately. Meeting this challenge, as you can guess, is going to require that we make substantial changes in our curriculum, our professional development, and how it is we use our data to improve. NAEP is telling us a lot about where and how we need to improve, and that's the point really behind all of the numbers. I think we are getting better, to be sure, and I'm convinced that we are on the right track, but we are still behind, as you know, and we don't like it. We're not interested in reflecting or perpetuating the inequities between us and the nation, or the inequities that many of our kids have to suffer through. Our job is to overcome the barriers that many of our kids face, and NAEP is helping us do that, and I hope with your help we can continue to make additional strides. Thank you very much.
Okay, as Linda mentioned, my name is Carlos Contreras. I work for Intel Corporation. I manage our U.S. education programs. We invest about $100 million a year in philanthropy all around the world in math and science. One of the reasons we do that is we are a large manufacturing base here in the U.S. It's about 2/3 of our R&D and our manufacturing is in the U.S. And 2/3 of our sales are outside the U.S. And so we, like any other companies, we see a lot of shortages in terms of folks that we're trying to hire. Our programs are mostly in three areas. One is around professional development. So one of the examples that was brought up here was math. We have something called Intel Math, or now called K-8 Math Progressions. You can read about it on Change the Equations website. And Linda was a huge part in helping us find that program and developing the program. It's an 80-hour professional development course, and we're reaching about 1,000 teachers a year. So not a lot of scale going on there, as far as we can in terms of what scale is. And all the things that were mentioned in terms of the deployments that are successful are the ones that are really have the follow-up for the teachers, that have that support for the teachers, that have that buy-in from the administrators, that have, it's linked into how the teachers are working together. We also do advocacy work. Common Core is something we've supported. Our retired chairman's been talking about standards for 20+ years. He's still on the board of Achieve, and he's still on the board for Change the Equation. He's a chairman, and so we've been very active in advocacy. And then the last category, which I'll talk a little bit more about, is around competitions. I have a very distorted perspective on education because I get to see the best every year. I get to see our science competitions, our Intel Science and International Fair, our Science Talent Search. I get to see the top kids, the top high school students every year in there, and we're, it's very inspirational, it's amazing, but we know that we're not reaching every single kid. And in order for us to compete as a nation, we have a huge resource that we're not mining, which is the kids that are in these schools. Once in a while, I see these kids emerge and come through, but sometimes I use this analogy. Maybe it's not the right analogy. The sports folks have this figured out, right? If you're a pitcher in high school, and if you throw a 90 miles an hour fastball, it doesn't matter where you live in this country. Somebody's going to find you. And yet, if you have these competencies and these skills, and you're not, we need to get more kids exposed to this, but it's pretty much a random, it's based on zip code, it's based on your parents, and we have to figure out a way to kind of break that. Otherwise, we're not going to be maximizing the talent that we have in this country. We can't compete by the numbers, right? China and India have a lot more people than we do, but we can compete by mining the talent that we have in this country. And so the other competition that we run is for schools, is around recognizing math and science schools. So every year we recognize 16 schools, elementary, middle, and high schools, and we bring them to DC. I'll just give you one example. This is a couple of examples. One of them is actually a rural school, which is what the data was showing before, not an urban school. This is a school in Oakland, Maryland. Anybody know where Oakland, Maryland is? It's in Appalachia. The school has 86 kids. It's 100% free or reduced lunch. It's the highest performing school district in the state of Maryland. And this place is extraordinary because of just where it is, the resources that are available. The school about 6 or 7 years ago, annexed a land that was surrounding the school. The principal got tired of cleaning up the junk and kids back there drinking beer and doing the stuff that kids do. And so she annexed the land, she inherited the land, and one day she was taking her elementary school kids, in the back for a tour, and one of the kids asked, there's a stream there, why is the water orange? Why is it coming out orange? And she said, well, I don't know, let's find out. And so they got some experts to go out there and do water samples, and what they found was the land is located right next to a creek, and what the history there was there used to be a railroad, and there used to be a coal loading area. And so when the mine shut down, they just dumped all the stuff, over 30 or 40 feet of just junk in the backyard of the school. And so the principal got she got the state, the federal, and they cleaned up the mess. And if you go now to the school, the students are monitoring the health of the stream. They have a bird watching operation going on. They're growing trees. One of the students found that the levels, I think turbidity or something, were elevated, and what they found is there's a fracking operation going on upstream in West Virginia, and they got permission from the landowner to go upstream and see where it was coming from. These are elementary school kids, and so I think what that for me, like I said, it's I see things that are so possible. I see the great potential that we have. And it's very inspirational, and at the same time, I'm very aware that the challenges that are there and the issues, and so it's very good to shine the light on the progress, and to say that we're a long way from getting there, and I can't wait to see the international comparisons, because I think that's where we need to look at. I think that's the bar that our kids need to go after. Okay.
So we'd like to open the session up to any questions that you may have. You can address it to an individual or general.
So I have a question. Hi, I'm Lynn Hoyer, formerly of DC Public Schools, and I'm doing my Einstein Fellowship in Congressman Marcana's office. Now that they can tell me really being a great champion for everything coming out of Silicon Valley. So Jack, my question is actually for you. I'm really curious if you disaggregate the data, how certain states on TIMSS and PISA results stack up to our international comparison, because I believe it's Shanghai, right, that is a separate entity unto itself. So can you talk about that international PISA test results in relationship to individual states? Thanks.
All right, so a couple things in there. So PISA so all these tests are different, right? So PISA is the international assessment administered by the OECD. Every 3 years, it's reading, math, and science, but it rotates which is the focal subject, so which one of them gets more emphasis. Within PISA, there are so the general original intent is to compare the OECD member countries. Then there are what they call partner countries, so a broader set who are non-OECD members, so generally sort of poorer countries or just non-OECD countries. And then there are some federal systems around the world that have some of their smaller subunits actually take the assessment and produce scores. So we do not have a score for every U.S. state, because most U.S. states don't participate. We don't have an actual observed score. Now, there are a couple different researchers who have used statistical methods to try and create scores for every state. You have to make a lot of assumptions to do that. At the end of the day, they're probably not really far off, but I can't tell you with any confidence that those are the real scores. Now, one of the things you're talking about, too, are these other special units. In the most recent PISA, Shanghai was included in the assessment as a special administrative unit, so not basically the city school area of Shanghai, and outscored the rest of any other participating jurisdiction. So I think the scale, they were the only 600, for example, in mathematics that I've ever seen of 15-year-olds in PISA. They completely outscored, generally, we're looking at countries like Finland that had to date been sort of the highest performers, and they completely outscored those. That, of course, if we have had states take TIMSS, we've had enough sample occasionally to try and produce something close to state scores, they would outscore any U.S. state if we had. I mean, I know that's true, even though I actually measure those every 3 years. There's a lot of questions about why. I mean, whether or not Shanghai is the correct unit sort of to compare to any U.S. state is a good question, right? There's not any state in the U.S. that is sort of sufficiently homogeneous and has dedicated a education system to producing sort of a single-minded excellence as Shanghai. And there aren't any U.S. states, I think, that would have the government come and visit every school and tell the kids that you need to perform at your highest possible level or you will embarrass China. It's very hard for me to envision a governor, even in Massachusetts, successfully getting every state or every school district in a state to participate. So it's kind of a difficult comparison. But it is clear that there are certainly jurisdictions around the world that greatly outperform others. And usually what you see is every 3 years when this happens, a whole host of governors and city superintendents and folks take field trips, right, to go try and learn and see what is it about country X or this province or something that seems to be what they're doing so great. And I think one of the things that I always find fascinating about that, it's difficult, first of all, to learn from only studying sort of one side of the equation, which is Mike's saying, look, we're looking at Boston, we're also looking at Cleveland, right? If you select on the dependent variable, like a researcher would say, then you're completely not picking up, even in a qualitative study, you're not going to pick up the other side. And I think that's a huge problem when we get a lot of these, what lessons can we learn only from high performers when compared to what question. And then sort of secondly, though, even if you did believe you were getting lessons, I think people are always surprised, right? So everybody went thinking, let's go to Finland, and what we're going to find is that technology is integrated into their classrooms, right? That everybody's got a laptop or something, that whatever the preconceived notion, and you show up and there's no technology at all, right? And it's not a factor. There's no one is learning to do PowerPoint as part of their science curriculum. They're not touching a computer until it's necessary for computation, right? And so coming in there with your preconceived notions because what we think works doesn't help a lot when we try and learn from sort of international comparisons either. I don't know if I really answered your question or just talked a lot. But, it was interesting.
Mike or Carlos, anything to add to that?
Nope.
I guess the only point I would make is that many of the companies in Change the Equation are multinational companies and certainly have a workforce and certainly have a consumer base around the world. So Change the Equation companies are very interested and concerned about being competitive in a world-class way. And it is a real issue of judging when we reach that benchmark and how we reach that benchmark. So I very much appreciate the insightful and nuanced comments that you're making, Jack.
Just one quick note on a issue Jack alluded to, and that is having a contrasting city or state or country by which to compare. I have to say we do it and have done it multiple times in multiple studies that we've done on why the pattern of results look like it does. And as Jack indicated, it does give you more confidence that what you are looking at is the right thing when you're looking at the high-end district, because you're not necessarily always sure what you're looking at is all that important to whether or not the NAEP or any other scores actually moved. But it is a politically tricky thing to do, particularly for a membership organization to pick out one of your members and use them as a bad example.
That's a non-starter.
But we do it. And we do it actually with their permission, and we actually don't even ask for their permission. We tell them that we're going to do it this way. We'd like to see them collaborate and cooperate with us. We've never had any of them say no to us, because what we end up always doing is promising to send technical assistance to them to help them get better. So far it hasn't worked in Cleveland, but we're still hopeful. But this point about using contrasting districts or states or countries, we've ended up finding to be enormously helpful in kind of sorting out what's important in producing the innate gains and what's really irrelevant. And technology, by the way, was one of those things that ultimately, as we sorted things through, didn't really prove to be all that instrumental in whether any district showed really substantial movement on NAEP, at least in math.
By the way, just on the technology side, I think that the statements are completely accurate. We, for obvious reason, we do a lot of studies around technology, and we did a study to look at the successful implementations of technology and the not so successful, and what were the reasons why. And there's some elements of when it's successful and why is it successful, and it's the same elements that you would find in any other educational intervention. So by itself, technology by itself is not the answer. It has to have a plan behind it.
Other questions?
Sharon Hesney, and I'm an Einstein Fellow working for Senator Franken, and I'd love to see that study of the successful uses of technology. I'm from Boston. I'm a high school math teacher and interested in those scores that we saw for Boston. For the cities that increased a lot, or the cities that did not increase a lot, can any of that be attributed to the change in the composition of the student population between 2003 and 2011 in that city? That's a pretty long time, and I can imagine that may be a factor in how their scores.
Yeah, I think the answer to that is no, for two reasons, and Jack probably knows technically better than I on the first, and that is, I think the way the sample is drawn, you'd be able to determine that. And two, most of the cities have actually become poor over this period, not less poor. And I think that was certainly the case in Boston, but it's I don't know of any of the TUDA participating cities over that period that became substantially less poor in a way that might have affected their scores. But even if they did, I think the way you weight the samples, you could have picked that up.
Well, so, I mean, I guess the short answer is it could be, but generally what Mike's saying is the pattern we saw. So I guess part of your question, though, wasn't just about increases or improvement, but it would be about sort of stagnation or not finding that. And so I would say, your answer is the same, but sort of spun differently, is that to some extent, places that we don't see statistical improvement, some of those cities are places that did get poorer, places where, as measured by eligibility for the National School Lunch Program, for example. And so, it's impossible to know, of course, for certain, had the economy not turned in those regions or something, what would have happened. But certainly we do see, perhaps some of that stagnation is certainly attributable or would appear to be explainable by the fact that the regional economies really vary quite a bit, and some of them took a big hit over that period.
I know this has become like a political issue in some cities where the question, and it's a reasonable question, comes up about whether or not the gains have been produced by something the school system did, or whether it's simply the school system is riding on the backs of a changing demographic that works in their favor. So far, and maybe this has come up in Boston. I know I've been asked about it when I've been up there. I know it's certainly been the situation here in D.C., but I don't believe there's any reason to think that the demographics or changes in demographics explain the size of the gains in most of these cities, or in any of them.
No, for the most part, it's the opposite. So we don't. We back to your other point. I mean, we don't adjust. You could use some sort of modeling approximations to adjust for this and try and look at you have to make a bunch of assumptions and think that you can hold constant sort of the effects of demographic factors. But certainly researchers do that, and we can do that, but we don't. We report out the scores as they are. So if the demographics change, and that has some sort of relationship with changes in the NAEP scores, that will be picked up in the score. So we don't try and partial out or control for that. But that said, my feeling from looking at these data, if we did adjust for them, the scores would generally be higher, right? For what we've seen around our urban districts in this period, if they've changed at all, they've probably gotten poorer. If they've changed at all, they've got more ELL students, not fewer, right? So you're going to find that where we have seen growth, these are districts that are growing in terms of achievement against sort of adverse conditions that we're not adjusting for.
Would they be more or less the same order, where some districts get affected substantially by demographic changes, both income and
Yeah, I think you'd see some folks that we're calling a tie in terms of not a lot of improvement, that if you adjusted, they would improve more. So the rankings would certainly change.
In the study that I referenced earlier, we actually did that. We adjust the scores by poverty, ELL, race, parental education, books and home, all of those typical predictors. It adjusts a little bit, and it is a little bit surprising who or which cities actually appear to add value and beat those variables to a greater extent than others. Who's overcoming those? Boston, by the way, is one of those that scores significantly higher than what you would have predicted given their demographic background. New York City is another one. DC is on the other end. They score substantially lower than what you would predict based on their demographics.
I think we have time for just one more question.
Agent and consultant with Change Equation. Based on your experiences in helping people use the data to improve, Mike, with in particular, do you have any advice for the two consortia of the states that are designing assessments where states can use the data not just to record but to actually support success?
Yeah, this is a difficult issue, and we've been doing some work with the data quality campaign around this, and it's a tough one for us because often the data systems in most major cities are far more sophisticated than what you see in the individual states. So in some ways the states this is not a uniform pattern, but it's often the case. And typically what helps us and inform our instructional reforms are not the kind of data that you find in most state data banks. What really helps us is more student-level data around the skills in particular content areas. That's not the kind of data that the states have or would have the capacity for, or even interest in trying to collect. So it's important what the states are doing in terms of setting up these broader data systems. And they're probably going to be helpful in terms of broader accountability issues. But when it comes to informing instructional practice at the classroom level, I suspect it's going to be the local data systems that drive that.
I'm hoping to change that.
I hope you do.
My agency actually has funded these grants to develop state longitudinal data systems since 2006. We funded about $550 million in state data system development. And one of the problems is that although we've been funding that development, we did not establish a set of sort of common data elements in a data model first, right? Which is what would make sense. You'd want to say, oh, let's make sure these systems all are interoperable and measure the same thing before we pay you to build them. We're a little bit behind on that, but we started all this year developing the version 2 of the Common Education Data Standards, which will be released in January. And I was just at one of the final meetings around the version 2 stakeholders group, and all the conversation in K-12 was, so what are you going to do in version 3? And what we're going to try and do within K-12 of version 3, and these things have to go from early childhood all the way to the labor market, in K-12 is to actually implement or look, is it possible to build common data elements to do exactly what Mike is saying? So looking at instructional practices that the states really want data collected on, but also breaking down the Common Core state standards to the individual strands to cover how much was covered on this and what was the individual student achievement. Because when those are in the field, if they're successful in 14-15, or even if they're late in 15-16 or something, I want to have the data systems already have the elements in place to collect the data we need to use them and not be late again on that. And so that's actually, all next year we'll be expanding through version 3 of our common data elements in order to support that. And that's a big priority within the department as well.
Yeah, I'm really delighted to hear that. You probably already know about what the big city school districts have done on the non-instructional side of the house, where we've developed a nationwide urban school performance management system with some 400 performance indicators in 4 broad non-instructional functional areas, and then collected comparable or near comparable data across all 400 indicators for each of the major urban school districts across the country. And it's at a granularity that really does help the systems improve their operational practice. And we're kind of working at the moment to translate that on the instructional and academic side. We're still probably another year or so away from having it up as a prototype, but we were so encouraged by what we were able to do on the non-instructional side that we're hoping to translate it over to the instructional piece. And I suspect at some point it's going to migrate its way up to the states. So.
Well, let me thank our panel, not only for doing an excellent job, but frankly, leaving us on an optimistic note, which is not always the way you feel when you've looked at data, particularly about the urban districts, but all the clear, obvious, well thought out, and wonderful plans that we have going forward. Frankly, for someone who's been in this arena longer than I'm about to admit from this stage, I really feel extremely upbeat, so I especially thank you. I want to thank everyone for joining us today for our salon. Please, no immediate urge. I know that our speakers need to scurry out pretty quickly, but we'll be glad to take any questions and try to forward them on as need be. But thank you again very much for coming.